Hello and welcome to the channel Understanding.Concepts.Of.Physics. We have been continuing around thermodynamics for some time now, and we are about to almost end this topic. And today we are going to see a very small topic. It will be a very short video, and it is going to finish in no time. Only topic we are going to see today is Carnot's engine or Carnot cycle. It's a very easy topic, very interesting topic as well. Let's see. Carnot engine and Carnot cycle. What is this? Carnot engine is basically a cyclic process which consists of the following four processes. So basically it's a engine consists of some cyclic process, one of the cyclic process, and cyclic process consists of multiple sub processes, and in this Carnot engine you have four processes. Now let's see one by one which kind of four processes it is going to contain. Now Carnot, before we go ahead, Carnot was a person whose name was Sadi Carnot, and he found out this Carnot cycle or Carnot engine. Now why are we studying Carnot cycle or Carnot engine? First of all is that because the efficiency of Carnot engine or Carnot cycle is maximum. Because the efficiency of Carnot cycle or Carnot engine is maximum, it makes it so special. So let's say we have four processes included here, and I have written all the four processes in different colors: isothermal expansion, adiabatic expansion, isothermal compression, and adiabatic compression. These are the four processes. Now let's see one by one in detail. Isothermal means the temperature will remain constant, and it's an expansion process, so volume is going to increase and the pressure is going to decrease, because volume and pressure is inversely related. So volume increases, the pressure will decrease, and AB is that portion of the graph which represents isothermal expansion. I have also made that in a color code, we'll see in no time. In adiabatic expansion, adiabatic processes are processes in which heat is kept constant, so heat, that is Q, is kept constant. It's an expansion process, so again the volume will increase but the pressure is going to decrease, and BC is the portion of the graph which is representing adiabatic expansion. And the third process is isothermal, so the temperature will remain constant. It's a compression. Means volume is going to decrease. As volume will decrease, the pressure would increase. CD is the portion which represents this process. And adiabatic compression, in adiabatic process is constant is heat, and compression means the volume is going to go down and the pressure is going to increase. dA is the portion which keeps on doing it. And now if you see, as we go from A to B, B to C, C to C, C to D, and then back to A, so it keeps on doing that. That's why it's called as a cyclic process. As usual, I have mentioned when we were discussing about cyclic process that area inside the cycle is what is called as the work done. And among all engines, the Carnot engine has the maximum efficiency. That makes so special about this engine. See, we can have this Carnot engine or Carnot, or maybe any engine or any cycle with many different kinds of process. Something like this. We can also have like this. We can have lots of different kinds of processes. All these graphs are PV graphs. PV graphs. But the point is, what makes Carnot cycle as Carnot cycle? What makes Carnot engine as a Carnot engine? Because the efficiency is the maximum for a Carnot engine or a Carnot cycle. So if you make an engine go through these following four processes, then the efficiency of that engine will become maximum. Okay. So that's what I have mentioned. Among all engines, Carnot engine has the maximum efficiency. Let's just quickly see the Carnot engine the PV graph, the indicator diagram. As you can see on the screen, just focus on where my lasers are pointing. So P is pressure, V is volume on the x-axis, and the y and the x-axis. Let's say A is my initial point. I'll start with A, and the volume is V1, P1, and at the process is going to B, then to C, then to D, V2, P2, V3, P3, V4, P4. So these are the volume and pressure ka value at different processes. The area inside the cycle will give you the work done. So the shaded region is the work done. Now if you see, The process goes from A to B. The graph is pretty gradual, and this process, this orange process, is what is the isothermal expansion. So if you see, I've just color coded. This is orange, this is green, this is yellow, this is purple. Orange, green, yellow, purple. So you can just identify it, pretty easily. I can just move this to the other side if you want to. Okay, so now if you see, we can just club it over. That's perfect. Now just to explain this graph, this process will be your isothermal expansion. Why is it expansion? Because the volume is low at this point and the volume is high at this point. So this is that initial volume and this is that final volume, exactly at this point. So the volume is increasing, that's why it's called as an expansion, and this is called as an isothermal expansion. If you remember the process, if you haven't seen my videos earlier, then I would request go and see all those process ka videos. And in an isothermal process, the graph is gradual. However, in an adiabatic process, the graph is much steeper. It goes drastically down. The rate of change is much higher. The second process is adiabatic expansion. Adiabatic expansion mein the graph will go steeply down, and it's an expansion. So expansion mein your initial volume was this and the final volume is this. So the volume is increased. So since the volume is increased, the expansion process is happening. Then process goes from C to D, but then this is a process which is an isothermal process, and because the initial volume was this and the final volume was this, because the initial volume and the final volume is smaller and the initial volume is greater, whatever is on the right hand side is greater and whatever is on the left hand side is smaller. So the volume is decreasing. As the volume is decreasing, this is a compression process. This is a compression, and because this is an isothermal compression, now the temperature is going to remain constant over here, and volume is decreasing, the pressure is increasing. So that's what I have mentioned here: temperature constant, volume decrease, pressure increase. Lastly, the process is going from D to A, where this is an adiabatic process because it's a very steep graph, and because the volume was high at initially and the volume is low finally, so the volume is going left to the left and the volume is decreasing. So this is also a adiabatic compression. So if you just club down this is isothermal expansion, this is adiabatic expansion, this is isothermal compression, and this is adiabatic compression. So this is the work done. All this stuff I have just mentioned over here, you can take a screenshot if you want to. You can just write it down in case if you have not been doing so. And this is what Carnot engine or Carnot cycle is. So in case you are still with me, subscribe the channel in case you haven't done so, and keep following the videos, or watching the videos and following it, making notes in a playlist manner, because every video has a link to the previous video. Thank you so much for watching. Bye.